Welcome back to the Energy Forum, a podcast from the Center for Energy Studies at Rice University's Baker Institute for Public Policy. I'm Ken Medlock, Senior Director of the Center for Energy Studies. Today, we're taking a closer look at hydrogen. Not long ago, hydrogen was seen by many as a key technology to help decarbonize the global energy system, but the optimism has tempered. This is not the first time we have seen this, as fuel cell technology and hydrogen as a transportation fuel made a brief appearance in energy circles in the early 2000s. It re-emerged onto the scene in the last few years and appeared to be ready to launch when supportive legislation, such as the IRA, was passed. Lately, hydrogen's potential to drive new market developments feels like it has taken a bit of a heat check. Rising costs, shifting U.S. and European policies, and a wave of project cancellations have slowed momentum. Still, there are pockets of supportive policy direction and optimism about hydrogen's future. So where does hydrogen really stand today, and what role will it play in the future of fuel? We're joined by two experts who bring both policy and real-world experience and insight. Ed Emmett, Fellow in Energy and Transportation Policy here at the Baker Institute, will be leading today's conversation. Joining him is Michael Graff, former Chairman and CEO of American Air Liquide and CES Directors Council Fellow.
Thanks, Ken. Mike, it's great to have you with us today.
Thanks, Ed. It's great to be here.
I know you've been involved in the hydrogen space, as we'll call it, for quite a while. A little background of what we're doing here relative to fuels of the future. You know, for the longest time, petroleum fueled everything. And then we went through a period where I think if you asked the general public, they thought it's either going to be electric vehicles or it's going to be petroleum. And it's a binary choice. Well, what we've discovered is that's no longer true. We now have this wide array of possible fuels going forward in each mode of transportation, whether you're talking about automobiles, trucks, trains, airplanes, ocean-going ships, barges. They're going to have a lot of choices, and hydrogen is one of those choices. So let's start with kind of a fundamental question. Where is hydrogen used today as a fuel, and what do you see as the major targets going forward for use of hydrogen as a fuel?
Sure. Well, Ed, again, thanks for having me today, and it's great to be with you. You know, hydrogen has been around for over 100 years in terms of industrial use. It started initially from a chemical standpoint for fertilizer manufacture, thinking about ammonia and those types of things. And that was really the mainstay for a number of years. And then in the 70s, going into the early 80s, as we started to see the disruptions of the oil embargoes, the dramatic change in oil prices over time with the formation of OPEC and a variety of things like that, hydrogen became critical to the fueling infrastructure even at that point in time. Because as you looked at the availability of what crudes we could actually obtain and utilize, the cost of light, low-sulfur crudes became very expensive. Back in the dollars of the day, you were looking at $30 or $36, whereas if you looked at a heavy, high-sulfur, high-metals crude, think Mayan, think some of the heavy crudes and Saudi, think other things, you were at $6. So an incredible differential between the two. But in order to upgrade those types of crudes into a usable a hydrocarbon that could be used for transportation fuels and that sort of thing, you needed hydrogen and large quantities of hydrogen to reduce the metals content, to reduce sulfur, to upgrade it, to hydrocrack it in some respects into the more usable fuels, and then to treat those fuels so they'd be environmentally friendly. So that became the next large use of hydrogen, which, while not used directly as a fuel, helped create the fuels that we all enjoy today as we think about how the future had evolved. And as time moved on, I mean, hydrogen has been used in a variety of different areas. I mean, it's used in semiconductors. We all know it as a fuel for space, a critical component to everything we did in the 60s and beyond, and even today. When we look at modern day use of hydrogen, all of those things are still in play. They're all still in vogue. From an industrial standpoint, is a fuel. Now it's being used for DRI in the production of steel in new processes.
DRI, I mean,
direct reduced iron. And I think that the evolution for semiconductors is really evolving with the advancing chips we see today. And interestingly, it really became full vogue into the transportation sector. Initially, we started to look at it during George W. Bush's administration significantly, and then it kind of faltered a little bit. And then it really started to come back over the course of the last 10 years as kind of a fuel of the future. And one of the largest uses today is in forklifts. If you think about material handling and mobility with forklifts, just in the U.S., there are over 50,000, and I've seen some recent numbers, it could be as high as 80,000 forklifts that utilize hydrogen in warehouse operations. So already from a mobility standpoint, that started to evolve. Then you started to look at the use of electric vehicles and a question of batteries or fuel cells. And we all know that batteries took off. We know the evolution of that as we see it. But there's a lot of merit to utilizing hydrogen in the right ecosystem, whether that's for passenger vehicles, probably even more so as we start to look at commercial vehicles, as we start to look at Class 8 tractors, as we begin to look at something that has got to carry large loads, a large payload on the highway or around town for that matter, and the weight of the battery pack you might need versus the weight of a fuel cell with hydrogen to go ahead and perform the same task. So you see that starting to evolve in many parts of the world, and certainly in the U.S. And then even from I would say, an airplane standpoint, from an aviation standpoint, there's a lot of work that Boeing, the Airbus, a lot of startup companies are now putting into utilizing hydrogen for propeller aircraft and now redesigning jet engines to go ahead and utilize hydrogen. And then finally, locomotives. There's actually locomotives in operation in Europe. There's locomotives in operation in Asia. And now we have some in California that are utilizing hydrogen.
Wow. There's a lot in what you just said. When you talk about hydrogen, you mentioned at the beginning ammonia. What's the connection between ammonia and hydrogen when we're talking about fuel?
So I think that ammonia can be used as a hydrogen carrier if, in fact, you want to use it as a fuel. So we all know that it's used for fertilizers and that sort of thing. But when you look at maritime operations, if you begin to look at ships and begin to think about how you might go ahead and utilize ammonia as the energy source to go ahead and power those ships, even in an industrial setting, you could burn the ammonia and actually use that in a furnace if you chose. You just have to redesign the burners and that sort of thing. And it's a mode of, I would say, hydrogen transport that we already understand and we can utilize and doesn't require maybe the same level of cryogenics that you might need for other uses or other ways of transport if you were to liquefy it. So there's different mechanisms that one might utilize. At the same time, there's a lot of merit in utilizing pure liquid hydrogen in almost all those services. It's a matter of how do you design the storage systems to make it work.
So when we talk about ammonia as a fuel, we're really talking about the hydrogen that's in the ammonia. And then what's the residual after it's burned?
So the residual after it burned, I mean, one of the benefits of hydrogen used as a fuel itself is that the only byproduct when burning pure hydrogen is water. So whether you combust that in any type of combustion mechanism, or even if you utilize it in a fuel cell to produce power, it combines with oxygen and it's just water that is the result. Now, when you utilize the nitrogen, you can still end up with NOx and those types of issues that you have to deal with. And so that's one of the elements that you would manage. But we know how to do that today with a lot of catalyst technologies that are in use for other reasons to control NOx.
So when we talk about pure hydrogen as a fuel, can you use it in its gaseous state or does it have to be liquefied?
So in the end, it's always used in its gaseous state. The question is how best to store and transport it and use it, depending on the mode of operation. It's very versatile. So one of the real benefits when you think about hydrogen, besides the fact that its only byproduct is water in use, is its energy density. So from an energy standpoint per unit of mass, or thinking about it from a weight standpoint, it has an incredible amount of energy contained to be utilized versus other fuel sources. I mean, just take kerosene as an example that you would use for jet fuel. For the same weight of hydrogen in kerosene, you get 3 times the amount of energy out of the hydrogen source itself versus what you would get from kerosene. So that has huge benefits as you think about that. The problem is, how do I contain enough hydrogen in order to go ahead and utilize it for long distance operation? So if I think about an airplane, or more importantly, maybe right now in current use, if I think about a commercial vehicle, you really want to go ahead and think about liquid hydrogen, given its densification, to go ahead and manage the storage capability of the hydrogen you need. When you do that, you can actually create, for example, a commercial vehicle that has the same utility that you have today with diesel. I mean, you can drive your 600 or 800 miles without refueling. You're able to go ahead and recharge your hydrogen storage in 30 minutes, just like you would to refill for diesel or something like that. And it works under all temperature conditions and a variety of things like that as well. So there's real benefits, but liquid hydrogen is very cold. Liquid hydrogen, if it's at atmospheric pressure, is basically 423 degrees below zero from a Fahrenheit standpoint. So you need highly specialized capability to contain that. And the storage systems for this are basically double-hulled vessels with a vacuum space in between in order to go ahead and maintain the cryogenic form of hydrogen itself. And that works just fine. It works just fine in many uses today. It's transported that way in tractor trailers on the road as we speak. And a lot of the new designs, when you think about aviation, if you want to think about large commercial use for trucking, even for locomotives or whatever the case may be, are rethinking the storage systems for fuel and how you would have to recreate that for each of those modes of transportation.
So let's talk about some of the modes of transportation. You mentioned forklifts. Those use liquid hydrogen?
So the forklifts typically don't. Typically,
Okay.
they use a very high-pressure cylinder. Typically, it's 700 bar to go ahead and contain the hydrogen to go ahead and fuel that forklift. It works just fine. It's very manageable. And you can do the same thing with a passenger vehicle. When you put it on a passenger vehicle, typically you would go ahead and utilize high-pressure hydrogen in that source rather than having to use cryogenic. It's when you start to load large amounts of hydrogen into something that the cryogenic aspect becomes important. I would add, however, that in order to go ahead and create the fueling infrastructure, even if you're going to go ahead and use gaseous hydrogen, it is most economic in order to transport the hydrogen and store the hydrogen, to do that as a liquid and then gasify it as you go ahead and charge a vehicle or you charge that cylinder.
Okay, well, let's talk about commercial trucking, long-haul trucking, for example. How do we get the infrastructure in place? For example, all the truck stops, they would have to put in cryogenic tanks, I assume. And then how would the liquid hydrogen be delivered to all those truck stops? And I guess, what's the tipping point that would make truckers go to liquid hydrogen? Or, yeah, I guess it would be liquid hydrogen at that point.
So I think you've got the technological issues that you address. You've got the economics that have to be addressed. And then you have the mindset of how you think about emissions and that sort of thing all kind of coming into play. In order to go ahead and have a truck stop or a fueling station of any sort, you would certainly design that with the appropriate type of storage tanks and safety considerations and a variety of things like that. And that's done every day. Then to transport that hydrogen, when you transport hydrogen today, the big industrial uses for refineries and for chemical plants, it's all basically done by pipeline for the most part. If you look at the Gulf Coast, we've got, up to 1,000 miles of hydrogen pipeline, if not more, and large storage systems. And you're able to go ahead and move the hydrogen wherever you need it as you think about that.
And when it's moving through the pipelines, what state is it in?
It's in a high-pressure gas.
Okay.
Right. When you look at transporting it on road, to go ahead and use large quantities, you can transport it one of two ways. Again, you could transport it as a high-pressure gas, high-pressure hydrogen, in special tubes that are designed to hold those pressures. But you really can't move enough if you're actually going to go ahead and start to charge commercial vehicles with the full charge of hydrogen that they need. So that's where you start to look at liquid hydrogen. And that's basically moved, similar to other cryogenic liquids, in a cryogenic trailer pulled by a Class 8 tractor, both locally and on the highway and that sort of thing. And that would probably be the normal mode. I think the other point is when you think about hydrogen itself, is what is the source of the hydrogen? And uniquely for each ecosystem you might be in, you likely can go ahead and produce that hydrogen more locally than thinking about having to produce that hydrogen at a very far distance. You can still do that with pipelines and that sort of thing, but it kind of changes the dynamic of how things might work.
So the general public, they hear about hydrogen as a fuel, and I guess they go back to the Hindenburg even and think, oh, hydrogen's so flammable and so dangerous. Your thoughts on that?
So, as I mentioned before, companies have produced hydrogen and utilized hydrogen for over 100 years. And they've done that very safely. For the last 70 years, many of the large industrial gas companies, as you know, I used to work for Liquide. I don't work there anymore, so I'm not speaking on their behalf,
Correct.
But certainly have a lot of knowledge of the industry. You know, they've been in this business for over 70 years. And they transport and utilize, and their customers utilize hydrogen safely each and every day. And safety is always the primary concern in making sure that you manage your systems, you deliver it appropriately, just as you would gasoline or diesel or other issues. And I think it is noteworthy if you think about the fact that this has been going on for over 70 years on highways and on pipelines. There's probably not a lot of events you can recall of any major safety issue with hydrogen, although you might recall it for other types of fuels and that sort of thing. So I think that the industry has a very sound record in how to manage this. They are very clear as to what needs to be done and do it each and every day. And even in the Hindenburg case, I think while a horrible disaster and something no one would ever want to see, hydrogen itself was not the fuel in that case, right? Hydrogen was used to lift the dirigible, and basically you were filling a balloon with hydrogen, which you would never do today. So I think recognizing all of that, I think that the safety performance of the industry has been pronounced and actually impeccable in many respects.
Well, you know, with growing concerns over the environment, as you mentioned, burning hydrogen leaves you with just water. And most people say, well, that's pretty good. And I know that there's some automobiles already in California and other places that are using hydrogen. But the production of hydrogen itself has an environmental issue. And so once we started looking into this, there's a whole rainbow out there, blue, green, pink, hydrogen. What do all those colors mean?
Yeah. And that's been an ongoing discussion. And I'll start with the premise that I'm partially colorblind. So I wouldn't know the difference between green hydrogen and blue hydrogen and pink hydrogen if I saw it, so to speak. But the reality is it's really talking about the actual production technology that's used and the source of the energy to produce the hydrogen as you look at the various forms. So the green hydrogen is hydrogen that's produced in a totally renewable way. So utilize some renewable source of energy. It could be solar power utilizing the sun. It could be wind-generated power. One of the things that we focused on over time, and I like to think about, is the off-gas from landfills. Basically a renewable off-gas that you can clean and use as a renewable natural gas to go ahead and produce hydrogen. But irregardless, that's what green hydrogen is. And it's really a matter of what is the source of where that comes from. The blue hydrogen, which I think is going to be probably the most prominent to be produced and used in the near term, is where you take something of a hydrocarbon, predominantly natural gas, and you basically synthesize that through steam methane reforming or autothermal reforming, same kind of a process, and you produce hydrogen and you capture the majority of the CO2 in the process and then sequester it. So it's not exactly carbon-free if that's your goal, but it's fairly close. I mean, you can recover 90% plus of the carbon if you chose to do that. And then the pink is produced from nuclear power. So again, totally carbon-free and utilizing electricity generated from a nuclear reactor to then go ahead and produce the hydrogen itself. All of those processes produce hydrogen, and the hydrogen itself is just a hydrogen molecule. So irregardless of the production process, it all works the same.
So here we are looking into the future of what's going to fuel various transport modes. What do you think is the most fertile opportunity for hydrogen to be used as a fuel? Ocean, trains, trucks, automobiles, airplanes?
You know, Ed, I think in the near term, likely the mobility sector, so to speak, to really focus on is commercial vehicles and heavy-duty trucks. If, in fact, you are looking to go ahead and decarbonize that part of the sector, because it costs money to do this. Let's be honest about that. Let's face that. You are in a place where, in order to do that, if you were to use batteries, even though there's a lot of great battery technology evolving and developing, the weight of the battery pack to have the kind of usability that you want, either on the road to go 600 or 800 miles without recharging something, or even in a return to base type operation. Think about all the warehouse operations with the large vehicles, or maybe it's your local utility that has large vehicles they have to deal with. You end up in a place where the weight of the battery pack significantly reduces the payload you can carry. Whereas the weight of the hydrogen and the fuel cell system itself is very comparable to what you have today with the current vehicle operation. So that creates a dynamic where if, in fact, you are going to electrify those larger vehicles, that hydrogen becomes a real focal point. And I think that's where you see a lot of folks looking. We already see that happening. We see that in Europe. We see that in Asia. And we're starting to see a bit of that in the U.S. as well, primarily, as you said, with the passenger vehicles in California, where you've got, 18,000 today going on 20,000. You do have the beginning of commercial truck operations, small, but beginning. But you have all the major manufacturers of the large commercial vehicles, the large tractors, the Class 8 tractors, all in this space and all trying to understand how they can do this in a better way. The real question is going to be, when does it get big enough in terms of demand for economies of scale to take over, and now the cost of that kind of vehicle is more affordable. You're starting to see that in Asia. You're beginning to see some of that in Europe. We've got a ways to go yet in the U.S.
So just to be clear, though, and I know when I first got into this, I was very confused, and I know the general public. If you're talking about a hydrogen automobile, you're talking about high-pressure gas. Mm-hmm. If you're talking about commercial truck, long-haul truck, you're really talking about an electric motor that the fuel source is a hydrogen fuel cell that generates electricity. Is that correct?
That's correct. And it's actually the same for the passenger vehicle as well. You basically remove the battery and you put in a fuel cell along with the hydrogen storage tank. And to kind of put that into perspective, the weight of the battery pack for a passenger vehicle could be as light maybe as 750 pounds to 2,000 pounds, depending on I would say, the vehicle itself, the design. I think that the larger batteries obviously are for longer use in order to get much more mileage and that sort of thing on the road. Comparatively, the weight of the fuel cell and storage capability along with a full charge of hydrogen for that same type of vehicle is only 250 to 300 pounds. So you could tell the weight difference there, right? And so whether it's the smaller vehicles or the larger vehicles, there's an immediate scale difference. So it starts to even change the payload of what happens in a passenger vehicle. And the other benefits of this, again, are their ease of use. So you are not waiting to recharge a battery. And a lot of good things have happened in battery technology, and the amount of time to recharge a battery has come down from the original 24 hours to a fast charge of 15 minutes to 30 minutes. Although if you want a full charge, you probably still need a couple hours and that sort of thing if you don't want to wear down the battery and prolong battery life. But with hydrogen, I mean, for a passenger vehicle, it's 5 minutes. And again, for the commercial truck, it's roughly 30 minutes. So you've got that ease of use to get the mobility you need today. And the other part of it is, and I think this is important, batteries typically don't perform as well in cold weather.
Right.
And we've seen some of the stories on that. And I know they're working hard to go ahead and find other ways to manage that. But you don't have that problem with a hydrogen fuel cell vehicle. So there's real benefits from a utility standpoint as well.
Okay. It seems to me, and this is a very small part of the transportation sector, but I enjoy when I go out and give speeches, I ask people about locomotives and what fuels them. And oh, it's diesel. I said, well, yeah, but diesel is the generator and it's electric motors on the drive wheels. It seems like that would be an easy transition certainly on the large railroads.
And it is considered as clearly a long-term option. It's probably going to take a while to be fully adopted.
Is that because of cost, or?
I think it's cost. And I believe if you look at what's going on in Europe, they're already doing some of these things. Companies like Alstom have been involved in this space for a while. Now in San Bernardino, you now have an operating railway for a commuter rail that is in operation utilizing hydrogen. So all that works. I think that they're still working to perfect the storage systems, looking at how you lightweight that, especially if you're going to use it on a plane, but lightweight that and still have the full usability that you want. And at the same time, you've got to go ahead and design some things to utilize that fuel cell technology versus what you already have in terms of the drivetrain for any vehicle, sure, including a train, right? So I think all of that takes time and effort. And then you see innovative companies that have looked at this and said, well, I can utilize the hydrogen in a fuel cell. I could also, if I have to, combust it. Now, you can question, do I produce the hydrogen only to combust it or use it some other way? Fine. But there's companies like Cummins, that have got all those technologies and are trying to figure out how they design a drivetrain of the future to make those things work.
So since you mentioned plane again, airplanes, rightly or wrongly, they seem to get a lot of public attention. We know that the UK has said by a certain year they have to use a certain percentage of sustainable aviation fuel in order to fly in and out of the UK. Where do we stand with hydrogen and passenger airplanes or even cargo airplanes?
Sure. So there's been efforts on demonstrating hydrogen as a fuel source for aircraft probably since the 50s. Experimental, trying to understand how it would work. But in recent years, and I mentioned this just briefly before, you now see the Boeings, you see Airbus, you see a number of startup aviation companies that are focused on electrifying an airplane and trying to figure out how they could manage that rather than use batteries, because again, the weight of the batteries is just too much if you think about long range flight and those types of things. But you could have a propeller-driven aircraft that can maintain good speeds and be utilized for commuter-type roles or to move cargo that could utilize hydrogen with fuel cells. And there's a lot of work on that right now. There's also a lot of work for smaller vehicles as you start to think about the air taxis and those types of things people are looking at. There's been a lot of work on that. Even startup companies like Joby are out there right now demonstrating these things. And again, given that weight differential, they see this as a great way to go. In addition to that, the real question for long-haul aircraft is, can I get there for the utilization of the jet engines today and design turbine technology that can utilize hydrogen or pure hydrogen? You can start probably with a blend maybe over time, but to utilize hydrogen as the main source. And there's a lot of work there right now. A lot of the engine manufacturers are spending time on that. They're looking at materials of construction. They're looking at ceramics. They're looking at the temperatures that you would have in the combustion zone as you think about the hydrogen itself. That's one thing. The other part of it is the storage. And this is where things really change in the aircraft design. Because as you know, in aircraft today, the fuel is actually stored in the wings. And so you've got that opportunity to utilize the entirety of the fuselage, basically for passengers or freight, luggage, whatever the case may be. Given the fact that we would be utilizing liquid hydrogen in order to have those long-haul flights, now you've got to rethink how you store your fuel on board. And so companies have already looked at designs. They already have designs. They have prototypes they're working on where you actually have those cryogenic storage containers in the fuselage itself towards the rear of the plane in order to hold the hydrogen as opposed in the wings. And I think that's the other part of this technology that's got to evolve if, in fact, you're going to get to that point.
So the final mode I have to ask about, ocean shipping. That's been a very interesting mode to look at because a group will come out and say, oh, LNG, liquefied natural gas, is the fuel of the future. And then you see the ships that are on order and majority are methanol fueled. But then you hear people talk about hydrogen and say, wouldn't it be great if they could just use the water that they're already on to somehow produce the hydrogen? Is that even a realistic opportunity? Or
So, Ed, there actually are some prototype vessels that do exactly that. They're few and far between right now, but it's a demonstration of what you could do. And for those types of vessels, they basically have an array of solar panels that generate electricity. They then desalinize and utilize seawater to go ahead and produce hydrogen and then power the vehicle, propel the vehicle, the ship. I think that we're a ways away from being able to do that, I think, for typical maritime use. The focus right now comes back to, would liquid hydrogen work? Would you use ammonia as a carrier to do that? Different ways to think about hydrogen for all the reasons we talked about before in a way that would allow you, as you enter each port, to refuel and do what you need to do, and yet go those long distances from a shipping standpoint to make that work. And there is work, and there are demonstrations right now of those kind of things going on. But long term, I mean, even IMO has looked at some of these things, International Maritime
Right.
Operations, to go ahead and think about how this would work and how that would play out.
Well, we could talk about this for a long time, Mike. It sounds as if you were fairly bullish on the idea of hydrogen long-term as a fuel of the future. You have any last thoughts?
So for me, absolutely bullish. I mean, I myself have been involved in designing and utilizing and producing hydrogen. And I think that I see hydrogen as kind of a perfect fuel once you have it, for all the reasons we talked about. And I do think as the world evolves and as things evolve, and with growing concerns, globally about emissions and a variety of other things, the world is always looking to make sure that energy is first available, it's affordable, and then it's cleaner. And I see hydrogen over time evolving in that matter. And if you've been able to use it for over 100 years in a very good way, in a very safe way, I think we can continue that moving forward.
Perfect. Thank you very much for being with us.
Thank you, Ed.
I appreciate it.
Great to be here.
Thank you.
Thank you for tuning in. Subscribe and follow the Energy Forum and the Center for Energy Studies for more expert insights on global energy trends. This episode was produced by Maram Hijazi. AV production was led by Andrew Murillo. Stay productive and never stop learning. Until next time, I'm Ken Medlock.